Welcome to Following Swift Evolution. Today we're gonna talk about SE0194, Derived collection of enum cases. And for that, I want to go back first to 2014, when I wrote this blog post about how excited I was with the new Swift enums and how powerful they were. And then I tried to use them to drive a UI segment control. So each case of the enum was represented by a segment in the control, and then we could switch between them and use the names declared to show them on the screen as strings and all that jazz. But then I found that it was not that easy at all. So I came up with this post where I explained that it was a pain in the ass because you had to do it manually and you had to make sure that it was keeping sync and all that stuff. On Swift 4.2, we have this new proposal that fixes this problem in the majority of cases. So we can start by defining a simple enum, like let's say like the directions north, east, south, and west. So this is just a normal enum that we can have in Swift in any version of Swift. But if we take a look at this, we will see that by default it doesn't give us anything that we don't expect. Like we have the cases, and then if we pick one of the cases, we basically has the hash value property, but we don't have anything else. What this proposal does is introduces this new protocol which is called CaseIterable, that if we take a look, it's pretty well documented. To be honest, I'm quite happy with this because for people that it's a newcomer on the language, like it's quite easy to read the header doc and start using it. But now that we have this enum conforming to this protocol, we have a new power on the enum that was not there before, and is that we can get all the cases for the enum. If we run this, we can see on the right bar that we receive an array with the 4 cases that we have declared. We can check what's the type of it, like by doing the type of declaration, and if we run this, we see that yeah, indeed it's an array of directions. And as I was saying, the order is basically respected by this. This is not something that the protocol enforces by itself, but in this case it comes from the magic of the compiler. So basically, when we are conforming an enum to this protocol, the compiler is able to automatically synthesize the implementation for conforming to this protocol. When the compiler is doing this, by default it just uses an array and it gives the order of the declaration that we have used. But if we take a look at the protocol itself, we will see that the only thing that the protocol specifies is that we need to return an all cases static bar with this type which references this, which is a collection where each element of the collection is basically one case of the enum. This means that we can go and, for example, if we were kind of crazy, we could go and implement manually this protocol and go a little mad and say, okay, I want to give you in not an array, but a set of these cases. So if we now run this, we will see that to start with, the order is already not the same, because obviously a set doesn't have order, but then if we check the type, we see that it's actually a set of directions. If we are expecting to be used CaseIterable in other scenarios, don't always assume that you're going to receive an array and that the order is going to be the same as the one defined in the source code, because that's not what the protocol defines. That's what the automatic synthesis of the compiler does by default. The fact that the compiler synthesizes an array, it means that we have all the power of collection with these all cases. This means that, for example, we can do an iteration over all the cases and we can print the direction we are going. And if we run this, as you would expect, we are printing all directions. But we don't need to stop here. Of course, because this is a collection, we can map over it, join it with some separator. And if we execute this, we will see that, as we expect, we just joined all the cases of our enum that we converted to strings and we joined with the join separator. But of course, the most simple thing that one will do with this is get all the cases and use it to get the count. And that's completely possible because again, this is just a collection. Now let's take a look at the not so good things about this. Of course, having the protocol is really nice and it makes everyone aware that this enum you can get all the cases of it. But what we really want is that the compiler synthesizes everything automatically, so we don't have to write and maintain the code and be careful with the bugs that we make. There are many cases where the compiler will not be able to do this. One of these cases is if, for example, we make a new enum here and we say that we have a language, we say that we have, for example, the awesome Swift, and then we have the dinosaur Objective-C. But then what about if we say, oof, you know what, Objective-C is so old that it's no longer available. In this case, for people that didn't know that this was possible, like you are just making the second case, the Objective-C case, unavailable. So you cannot actually write it. You can see here that it's not even suggested by Xcode. If we now go and we conform to CaseIterable, you will see that the compiler will complain saying that this enum doesn't conform to CaseIterable. Of course, it doesn't because it has one of the cases where the automatic synthesis doesn't get executed, and it's when you have an unavailable case on the enum. The second case is when you have, let's say, for example, we have a food enum and we have, I don't know, pasta, and then we have pizza. Imagine that we want to put like the toppings of the pizza, so we say, okay, let's put a string here for the toppings, and we say now, okay, please give me all the cases for this. So if we run this, the compiler again, it will complain that this type doesn't conform to CaseIterable. Basically, it's because the compiler is not doing it automatically for us. And this is because this enum has an associated value. One of the cases, at least, of the enum has an associated value. And in these cases, the compiler will not run the automatic synthesis for us. It's true that if all associated values were also case iterable, imagine that if instead of a string we had an enum for the toppings, in that case, it's possible that the compiler should be able to do it, and maybe in the future it will do it, but for now they wanted to keep it simple and it just does it if the enum itself, all the cases are just simple cases without any associated value. Any enum imported from C or Objective-C will not be able to be case iterable. And if you were thinking that you could retroactively add the conformance by extending it yourself, I'm sad to mention that that's not possible. You can define case iterable in the enums directly on the type definition, or if you are on the same file, and that still works. You can see here that everything works. But if you are trying to do this outside of the same file, or imagine that it's imported from another library, you are not able to retroactively add conformance to the type. This is basically for safety, in line with all the other automatic synthesis that the compiler does, like equatable, codable. It's basically because automatic code synthesis, the way that Swift sees it, is really a feature for the owners, for the creators, the original creators of the type, and it's not to make retroactive conformance other types that you don't own. But of course, as you have seen before, you're always on your right to conform to the protocol yourself. You are basically back to square one. This is the same thing that we had before. The only thing we gain is that now we have a protocol, so it's more explicit and more standard for everybody to say, okay, I can give you all the cases that I have. But all these issues is, for example, I made a mistake now and I'm not returning all the cases. So this is a potential bug. Not only that, but if we expand this, we need to remember always to change the all cases. Furthermore, if you are doing these to types that you don't own, it's super dangerous because any update on the library, or imagine that you're doing to a framework from the operative system that can basically change directly without you knowing it, or without updating your app or compiling again, this can provoke many issues, and that's why obviously the compiler doesn't do it automatically. The solution for this, it's basically as it was before. You can use metaprogramming, you can use code generation. I recommend the tool Sorcery for it, that basically will write at compile time all of this for you, but because you control it, you write the templates that you want to generate and how you want to generate it, you are not restricted by any of these only with associated values or whatever. You can just conform to your protocol and you write your own code generation. Another solution that it doesn't help but it prevents future errors is basically write a function that makes a switch over all the cases that you know, so when you add a new case, at least you will have a compile time error and the compiler will tell you you are missing a switch branch here, and then you know that you need to update your all cases. But of course it's all a little tricky because there is nothing telling you that these two things are related apart from a comment that you write. So that's all for the normal stuff that you are going to do with CaseIterable, but a curious thing is that CaseIterable, then maybe the name implies that because it talks about cases, that it's all about enums. But that's not true. The only thing that this protocol tells you is that this type can give you all the values that it contains. One crazy thing that you could do is like extend bool, conform it to CaseIterable, and obviously the compiler will not do it for you, but it's not that hard to basically write it yourself. So now if we run all cases, we have an array with all the possible Boolean cases. I don't know how useful this is, but it's something interesting because the name doesn't really give you this clue. But this is because during Swift evolution, during the evolution process, the core team decided that it was better to give the name that basically defines the primary function of this protocol, even if then you can start doing questionable things like this one. So that's all what I wanted to say about this new feature of Swift CaseIterable. I recommend you to check the link to my blog post in the description where I use this to update the use case for the segmented controls. And that's it for today. Thank you for watching and subscribe and like if you want to have more videos like this one following Swift evolution.